All right, I'm going to start by reviewing some things that we learned last year in seventh grade concerning inequalities. So, and it's not much. And then I'll go into eighth grade inequalities, okay? All right, so the first thing I want to go over is what an inequality is. An inequality is a math statement where you may have an expression that may not necessarily be equal to another expression. And when I say may not necessarily, it can be, but it doesn't have to be. So, for instance, it could be what we call less than, greater than, or less than or equal, or greater than or equal. So sometimes it can be equal. Again, it doesn't have to be. All right, so this symbol is your greater than symbol. And I remember it because it kind of looks like a broken G to me for greater. And this symbol is the less than symbol. And you're going to have to feel free to pause the video when you need to and take these notes because I'm going to go kind of quickly, okay? And I call it the bent L for less than. If it has a line underneath it, that stands for equal to. So because it has greater than on top, you're going to read this as greater than or equal to. And because it has less than on top, this one, you're going to read this as less than or equal to. Remember, the little line means equal to, okay? So now I'm just going to go over some rules for graphing, and then we'll get into solving, all right? But you can't solve them and show the solution without knowing how to graph. Okay, so rules for graphing. So again, pause the video if you need to and take notes. So if you see these symbols, less than or greater than, you're going to draw what we call an open circle. And today for eighth grade or algebra, you're going to learn that you can draw something else besides an open circle. When you get ready, well, you can draw something that relates to the open circle when you get ready to write in another notation. There's two notations you can write your answer in. It's called written notation and interval notation. But if you don't see the lines underneath, you're going to put an open circle on your graph at that whatever point number you're supposed to start at, okay? That means that that number that you're starting at will not be part of your solution. So for instance, let me give you something like this. This is read as your x or your solutions have to be greater than -4. Okay, there are several numbers that are greater than -4, but to show all of them, what we do is we graph and we shade. And this should be coming back to you. So I'm going to put -4 here and list a few numbers to the right and to the left. At -4 will not be shaded in. Will not have a closed circle on it. It will have an open circle at -4 because I can't say -4 is part of my solution because -4 is not greater than -4. It's equal to it, but it's not greater than -4. So to show that that solution is not part of that number is not part of our solution, we want to make sure we put an open circle, okay? All right, but all the numbers that are greater than 4 to the right, -4 to the right of it, they're going this way to the right. But what we do is we shade in all these numbers to represent that all those numbers, even the decimals and fractions in there, are greater than -4. And we also shade the arrow in to indicate that our solutions keep on going. So we have an infinite amount of solutions to an inequality, guys. You have to be careful on something like this when it says graph 7 greater than x, because 7 in this particular case is greater than whatever x value you pick. In other words, 7 is greater than x represents your answers. So 7 is greater than your answer. So I'm going to graph this, but keep in mind that 7 has to be greater than the answers that I'm choosing. 7, a few numbers to the right will be 8 and 9, and then 6 and 5. If 7 is not greater than or equal to my answer, so I'm going to put an open circle on 7. But think about what number 7 is greater than. 7 has to be greater than some numbers, okay? 7 is greater than what numbers? Well, 7 is greater than 6, 7 is greater than 5, 7 is greater than 4. So 7 is greater than all these numbers to the left. This isn't your numbers or your answers are greater than 7. Your answers are not greater than 7. If 7 is greater than your answer has to be less than 7 then, if that makes sense. Okay? So what I always tell my students to do if they get confused when the number is on the left side of the inequality, to rewrite it. To rewrite it, you flip everything. So your x moves to the left, your 7 moves to the right, but you would even flip the greater than symbol to less than. Now it's easy to see that all your answers need to be less than 7. Okay? And something you can go off of, if you see this symbol, find the arrow end. Like you see the symbol right here. Find the arrow end that matches that. This arrow end matches this symbol, so shade in that direction. Or this symbol. Well, this arrow end matches this symbol, so shade in that direction. But that little trick only works if your variable is first. Like here, your variable comes before your inequality. Here, the variable comes before the inequality. So that little trick of find the arrow end and shade in that direction will only work if your variable comes before the number in your inequality statement, okay? Okay, let's take a look at this part. All right, here. If you see the little equal to symbol, then I need you to draw a closed circle on the graph. That closed circle is going to indicate that that number is part of our solution. An open circle indicates that it's not. A closed circle indicates that the number actually is part of the solution. Now let's talk about how we graph these things. So there's a number 2, a few numbers to the right are 3 and 4, and to the left are 1 and 0. All right, because it has equal to on it, I'm going to put a closed circle on the number 2. That closed circle indicates that 2 is maybe not less than 2, but 2 is equal to 2, and it says equal to on it. It says x is less than or equal to 2, okay? So 2 may not be less than 2, but 2 is definitely equal to 2. Now, to shade in all the numbers that are less than 2, I just go to the left. These are all the numbers that are less than 2. All right, let's take a look at this other one. -5 is greater than all of my answers. -5 is greater than or equal to. Because X stands for your answers, guys. So if -5 is greater than your answers, and let's go ahead and draw the line. And keep in mind, negative numbers, they're turned around differently than positive numbers. So I know normally you count 5, 6, 7, but this is -5, -4, -3. They're the opposite. And then 6 and 7 are on the other side. They're not like the positive side of the number line. You kind of reverse it, okay? Closed circle on -5 because -5 is not greater than itself, but -5 is equal to -5. Now this says that -5 is greater than all of your answers. So -5 is greater than every answer that you need to shade. Well, what numbers on the number line are actually, are numbers where -5 is greater than it is. So is -5 greater than -6? Is -5 greater than -7? So I'm looking for numbers that where you can see -5 is greater than that particular number. So -5 is greater than this number. -5 is greater than that one. -5 is greater than everything over here. So I'm going to shade in that direction. But it's best if you see the number first to rewrite your inequality statement. So put your variable first, then put your number. But if you do that, you must switch the symbol from greater than or equal to less than or equal to. And then you just have all your answers are less than or equal to -5. And it's much easier to see that way. Or if you have the variable first, you can look at your inequality symbol and find the arrow end that matches it. But that's only if you have the variable first. All right, that's what I wanted to show you for that particular part. I just wanted to go over graphing and shading, okay? Solving, pretty much, we're good to go. I'm not going to go over the golden rule for solving inequalities. I think we should remember that. Let's see. All right, yeah, let's talk about it real quick before we get into solving, okay? All right, so we know how to graph solutions, but do we know how to solve these inequalities? So key thing is you solve an inequality just like you solve an equation, guys. But you got to remember the golden rule, and you're going to say, well, what is the golden rule? Okay, here's the golden rule for solving inequalities. When you multiply or divide by a negative number, you must remember to flip your inequality symbol, guys. That's the golden rule for solving inequalities. If you multiply or divide on both sides by a negative number, you must flip your inequality symbol when you do it. Okay, so we're going to take a look at some examples, all right? Make sure you pause the video and get all this written down, please. Okay, let's go back and take a look at some examples. Okay. But before we get into 8th grade multi-step inequalities, I'm going to teach you interval notation. I didn't teach you that last year, so something new, okay? All right, so interval notation is another way of expressing your answer as an inequality. That's not worded right. Should say expressing. That should say as and. That's what's throwing me off. Okay, sorry guys. All right, so it uses parentheses and brackets. You're going to have to remember that. Please write this down. Interval notation. It's just another way of writing your answer. We normally write it in what we call written notation, but you can write it in interval notation. This is new. You'll see it when you get to college. I want you to understand what it is. All right, so it uses parentheses and brackets to show where your graph starts and ends, guys, okay? So on a graph, if you have an open circle on your graph, if you would have written an open circle on your graph, or you drew an open circle on your graph, when you write your answer in interval notation, you're going to use parentheses, okay? Use when you have a graph starting or ending on an open circle. I say ending because we're going to get to compound inequalities, guys. Don't worry about that today. But sometimes the graph will start and stop instead of start and keep going on forever. Don't worry about that today, like I said. So basically today, when you have a graph that starts with an open circle, you can write your answer in interval notation by using a parenthesis. So just remember, open circle and parentheses go together, okay? But if you have a graph that starts with a closed circle, guys, you're going to use a bracket. So remember, closed circle and bracket go together, okay? And some people get confused about which way the bracket opens or which way it's turned or which way the parentheses is turned, left or right. But we'll talk about that too once we solve. It'll make sense if you draw the graph. You just kind of match the graph up in the direction of the graph to the way the inequality, the way the bracket or the parentheses is turned. But let's get into some examples, guys. Keep in mind the golden rule. If we multiply or divide by our inequality by a negative, let's not forget to flip our symbol, okay? All right, so what we're going to do on these examples is we're going to solve, graph, and then write the inequalities in interval notation. Okay, let's look at number 1. So you have parentheses. You're solving the same way you solve an equation, so we'll just use the distributive property. 4 times x is 4x, and 4 times 3 is plus 12, greater than negative 24. And we did these last year. All right, I'm going to draw my line. So I get rid of the plus 12 first by changing the sign. So I end up with 4x greater than negative 36. Divide both sides by 4, and I'm dividing by a positive. So I'm not going to be flipping the symbol. You only flip the symbol if you divide or multiply by a negative. So here I have x greater than -9. Now this is what we call written form. This is what we call written form because you just wrote your answer out, x greater than 9. So I'll come here and I'll put my -9, and the numbers to the right are -7 and -8. The numbers to the left are -10 and -11 because I'm on the graph part. It is greater than, therefore it is an open circle because there's no equal to symbol. I'm going to put an open circle on -9. And greater than goes to the right if your variable comes first. And the variable does come first. Goes to the right. Or you can say this arrow end looks like that inequality symbol. So you just shade to the right. Now here's the new thing, guys. Interval notation. So if you have an open circle, you must write interval notation with a parentheses. So what you're going to do, if you get confused about whether to turn your parentheses open facing to the left or open facing to the right, all you do is look at the direction that the graph is shaded in. Well, the graph is shaded to the right. So you want your parentheses to face open going to the right. So you're going to use this to start off with. So we start here at -9 and it keeps going to the right. So you're gonna open your parentheses. Why open? It's an open circle. Excuse me, why parentheses? Because it's an open circle. But it's opening to the right because the graph is shading to the right. You're gonna put your -9 where it starts, and it continues to go to the right. But if you look to the right, these numbers just keep getting bigger and bigger and bigger. So it may start at -9, but it keeps approaching positive infinity, guys. Okay? -6, -5, -4, -3, -2. And these numbers just keep going on and on and on and on and on, and they don't stop. So it starts at -9 and it approaches positive infinity. Anytime you have an infinity symbol in your interval notation, use parentheses next to it. Okay? So this just helps me to see that we start at -9, and at -9 it's an open circle, and I know that because open circle and parentheses go together. And then it continues to go to infinity. And remember, anytime you have an infinity symbol in your interval notation, always, always, always use parentheses, okay? Alrighty, let's take a look at number 2. Number 2, I'm going to put an imaginary 1 here for the coefficient of x, 1x, and then I'm going to use the distributive property. -3 times x is a -3x. -3 times +2 is -6. And then it's greater than 4. And what I do is I combine my like terms. So I see 1x and -3x alike. That gives me -2x minus 6 greater than 4. Now I got a basic two-step. Add 6 to both sides. Just change the sign. So now I end up with -2x greater than 10. Now this time I'm dividing by -2. Because I'm dividing by a negative, I'm going to flip the symbol. So I got to divide by -2. So my greater than symbol is going to flip to, let me use a different color. My greater than symbol is going to flip to less than. So I got x less than -5. Let me write that -5 a little better. Remember, if you divide by a negative or multiply by a negative, flip the symbol. Okay? So let's take our -5 and then put numbers to the right and to the left. It's x less than -5. It's an open circle on the graph. And my variable is first. I can just find the arrow end that matches the inequality, or everything less than -5 is to the left. I could just say that. Okay, now be careful. For interval notation, this thing starts at -5, and it continues to go to the left, and it approaches not positive infinity, because we go -6, -7, -8, -9, -10. It approaches not positive infinity, but if it continues to go left, it is approaching negative infinity, guys. All right, it's approaching negative. Now be careful. If it's approaching negative infinity, then you're not going to write this thing at, and I don't want to say starts at -5 now, even though I put the -5 first. And let me go back. I'm going to say that we're going to write this thing from right to left. So that's going to be the best way to explain it. Excuse me, not right to left, but left to right. Let me go back up here. That's going to be a better way of explaining it, because I don't want to confuse anybody. You're going to write it from left to right. So go back and erase what I had. On the left was -9, and it continued to go to the right to positive infinity. And maybe that will help you write that. Okay, so what's on the left here? So on the left here is negative infinity. And we're writing it left to right. So we go from negative infinity to -5. This went from -9 to positive infinity, left to right. So you're going to start from left to right in interval notation. On the left was negative infinity. Anytime you write an infinity symbol, use parentheses. And it approaches to the right to -5. And -5 has an open circle. So we're going to do parentheses. Remember, parentheses and open circle on the graph go together, okay? So yeah, let's just stick with left to right. Read the graph from left to right, and that will be better. That will help you with interval notation. Left to right. Left to right. And just focus on the graph to help with left to right. This is left. That's going to the right. Negative infinity is on the left. And it's going to the right to -5. Okay. So hopefully that will help. That will help you. Okay, let's take a look at number 3. I hope so, guys. If not, pause the video and let me know, because I don't want to confuse anybody. All right, so I'm going to start off with 7x. Use the distributive property. That's -2x. -2 times -4 is +8. Less than or equal to -2. And I'm going to combine like terms. They're on the same side, so I can combine them. That's 5x plus 8 less than or equal to -2. Remember, before you can combine like terms, they got to be on the same side of the inequality or the equal sign. What I don't want to see, and I've seen, I think 1 or 2 people doing this in my class. I've seen someone doing this. You don't do that, because these two numbers, those two terms are not on the opposite sides. You can only do the opposite of an expression if they're on opposite sides of the inequality symbol or equation. So in this particular case, all you can do is combine like terms. That's going to give us 5x plus 8. I don't like my 5. And then you're going to have less than or equal to -2. And I'm going to subtract 8 from both sides. So that's 5x less than or equal to -10. I am dividing by -5, my +5. I do not flip my symbol. Don't worry about it. You're dividing by positive. So here x is less than or equal to -2. Again, this is called written. This is called written form when you use the variable, okay? Over here is when we do interval notation. But this is called written form. So I'm going to put -2, -1, 0. Just listing the numbers on the number line. Because it does have the equal to symbol, I'm going to put a closed circle on -2. And my variable does come first. The arrow end that matches the inequality symbol is to the left. Or you can say this is less than. That's less than or equal to. Everything less than or equal to -2 is a closed circle at -2, or those numbers that are to the left of it. So you shade to the left. Now you're going to read this thing from left to right to help you with interval notation, okay? On the left, negative infinity is shaded in. If you shade it in to the left, that's negative infinity. Because these numbers are getting smaller and smaller, actually, okay, as we go to the left. And it goes negative infinity, it goes up to -2. So again, I'm going to write it from left to right. So what's on the left with negative infinity? Put parentheses. And on the right, we have -2. Now be careful, because -2 has a closed circle. Well, you can't write a bracket like that, because that's indicating that it's opening up, starting at -2. And it doesn't. It actually, if you're writing it from left to right, you need to close it out this way to indicate that it stops at -2. It does. Use a bracket because that's a closed circle. And you just got to remember, closed circle has a bracket on it. Now I know this bracket is turned to it's open toward the right. And this bracket down here is open toward it's opening toward the left, okay? But that's because it stops at -2. The only time you would use this bracket, have it turn this way, is if you were starting, if -2 was on the left and it was approaching something like positive infinity on the right. Then you could turn it and open it this way, okay? Because -2 would be on the left. And you would have to open it up going to the right to indicate that it keeps going towards some other number. Just know that anything on the left will either be a parentheses or a bracket that opens that way. It'll be a parentheses if it's an open circle. It'll be a bracket that opens this way if it's a closed circle. And anything on the right will be a parentheses or a bracket that closes that way, okay? And I say closes that way because that's the end. On the right is the end. Again, it will be a parentheses, like if it has an infinity, or an open circle, or this a bracket if it has a closed circle. So let's take a look at 4. I'm going to put an imaginary 1 and use the distributive property. -8x, and a negative times a negative is a positive. And then I'm going to combine my like terms. -8x and -1x makes -9x. I'm going to get rid of +8 with a -8. So I get -9x less than or equal to -36. Now I need to divide by -9. Because I'm dividing by a negative, I'm going to flip the symbol. Making a video. I'm making a video for this other group.
I thought Tim was over here. I'm trying to get Miss Jump Drive.
I haven't seen her. All right, so because we're dividing by a negative, I'm going to flip the symbol from less than or equal to greater than or equal to. And a negative divided by a negative is a positive. Okay, I'm going to start my graph. And it has equal to symbol, so I'm going to put a closed circle on -4. The variable is first, so I can find the arrow end that goes to the right or just shade to the right because it's greater than. Then we're going to write this thing from left to right. Now remember this. These are the only things that can go on the left, and these are the only types of notations that can go on the right, okay? Okay, so write it from left to right. So left to right. On the left is -4. And to the right, we are going toward positive infinity, guys. Because it's a closed circle, I'm going to use the bracket at -4. And it's going to approach positive infinity. So I'm going to use a parentheses. Never use a bracket around parentheses, around infinity, okay? Never, ever, ever use a bracket next to infinity. Okay. Okay, let's try one with variables on both sides. If you have variables on both sides, you just make a decision about which one you want to remove first. I don't care which variable, just do the opposite, which variable term. So I'm going to get rid of -2x with +2x. Now I can do the opposite because -2x and 6x on opposite sides of each other. So that gives me 8x plus 1 less than 9. Now you got a basic two-step. Get rid of +1 with -1. Swing it with 8x less than 8. Divide both sides by 8, and you're dividing by a positive. Don't worry about flipping the symbol. You get x less than 1. Then you just take care of your graph. 1, 2, 3, into the left, 0 and -1. Again, this is written form. It's an open circle on 1 because it doesn't have the equal to sign underneath it. And everything less than 1 is to the left. Or since your variable is first, you can just say, well, I can just find the arrow end that looks like that. So now I'm going to write the left part starts over here and it goes here to the right side. So on the left side here, we have negative infinity. And on the right side here, we have positive 1. So I'm going to start off with negative infinity. And on the right side, I'm going to put 1, but it's an open, so I'm going to put parentheses. That's interval notation. All right, you pause the video and try number 6. All right, this is what you should have, guys. And I'm going to get rid of 5x by changing the sign. You may have gotten rid of 2x. It's up to you. That leaves me with -3x minus 1 less than or equal to 20. And I'm going to work it the other way just in case somebody else worked it the other way, okay? I'm going to add 1 to both sides. So that gives me -3x less than or equal to 21. I'm dividing by a negative. So I'm going to flip my symbol. So less than or equal to will flip to greater than or equal to. And this will be -7. Now, before I do the graph, I'm going to show you if you would have done it the other way and gotten rid of 2x, what it would have looked like. To get rid of 2x, you would have to change the sign. So some of you may have done it this way. Still get rid of 20 with -20. -21 less than or equal to 3x. But this time when you divide it, you would have ended up with -7 less than or equal to x. If you don't like the number being first, you could have just rewritten it by flipping everything around so it looks like this. But if you flip everything around again, this less than is going to flip to greater than if you flip it around to look like this, okay? All right, but anyway, in any case, we're graphing the same expression. All right, close circle on -7. And I'm going to go by this. I like for my variable to be first. Everything greater than -7 is to the right, or you can say this arrow end matches that inequality symbol. And to write it in interval notation, You just go left to right. On the left, you got -7. And on the right, it's approaching positive infinity, guys. Be careful when you start on the left. You start on the left. I'm just going to use L and R. You're going to put a bracket over here because it's a closed circle at -7. And to the right is positive infinity. So you're going to put a parentheses because we never put bracket on an infinity symbol or next to an infinity symbol when we're writing it in interval notation. All right, again, I hope this is making sense. If not, then just let me know. Okay, let's take a 7. Take a look at 7. You're going to put an imaginary 1 right here so I can have something to distribute because you're definitely not going to distribute that 3. All right, so we're going to start off with 3 and then use the distributor property. It's going to be -2x. And -1 times -7 is +7. And bring the rest back down. On the left side, let's go ahead and combine 3 plus 7. 3 plus 7 is 10. Now I can get rid of one of these. I'm going to get rid of -6x by changing the sign to a +6x. Now, if you want to, you can get rid of the -2x. It's completely up to you. So here we end up with 10 plus 4x less than or equal to 34. And guys, as you can see, I'm running out of room. So I'm going to erase some of this so I can have some room to work. Now I'm going to get rid of 10 with a -10. So I have 4x less than or equal to 24. And I got to have room to work up here. I am going to divide by +4. No need to flip the symbol then. And x is just less than or equal to 6. And then, of course, it's from there, it's just do the number line and interval notation. Because it has the equal to sign, I'm going to put a closed circle to indicate that 6 is part of my solution. And I'm going to shade to the left because that's everything less than 6. And I'm going to write this thing in interval notation from left to right. Well, what's on the left? On the left, it's approaching negative infinity. And on the right, it's stopping at 6, okay? So negative infinity to 6, but 6 is a closed circle, so put a bracket there on the 6, okay? Ooh, I can't do all of these. Okay, yes I can. Let's see. I'm trying to find some that I might skip 8. I'm gonna skip 9 too because you all should know that here you have an imaginary 1 to use that. Okay, let's take a look at 10. I'm gonna put an imaginary 1 right here to that because there's nothing to distribute. I'm gonna do 10. -1 times 3x is -3x. -1 times +3 is -3 minus 2x greater than, use the distributive property again, -4x. -4 times -2 is +8, and bring down your -2. And I'm going to start by combining some like terms. So on this side, I got -3x and -2x, and on the other side, I can combine +8 with -2. So let's go ahead and combine on the left. That will give me -5x minus 3 greater than -4x plus 6. All right, I am going to get rid of -4x by changing the sign. So again, when you simplify each side as much as possible, then start trying to get rid of some stuff by doing the opposite, okay? That gives me -1x minus 3 greater than 6. Now you just got a basic two-step. So change -3 to +3. So it gives me negative 1x greater than 9. I'm going to have to go up here so I can have some more room, okay? But you're going to divide both sides by -1, guys. So since you're dividing by a negative, greater than is going to flip to less than. It's going to be x less than -9. Okay, let's start off our graph. Remember, negative numbers the graph doesn't look the same as positive numbers. Positive numbers, we start off with 9, we go to the right with 9, 10, 11. But since they're negative, we won't have negative 9, negative 10, negative 11. We'll have negative 9, negative 8, negative 7 to the right, okay? It is an open circle because there's no equal to sign underneath the inequality symbol. Open circle at -9. Looking at everything that's less than -9, which is everything to the left of it. And just shade that way. Now all you have to do is put it in arrow rotation from left to right. On the left, we have it's approaching negative infinity, and it's going on the right to -9. Negative infinity to -9. -9 has an open circle, so please use the parentheses. Just make your interval notation match your graph, basically, okay? Okay, I'm going to talk about some special ones, and guys, if I'm going too fast, again, just go back and rewind the video and just stop it and write, okay? All right, these look a little different from the ones that you saw on the worksheet, so I decided to put these in. You've seen these with equations before, so I just wanted to reiterate it with inequalities, okay? And then we're going to talk about some special cases. Okay, let's take a look at number 1. To solve something like number 1, what I would do is find a common multiple between 6, 3, and 4 and get rid of the fraction. If you wanted to find a common denominator, you could, but I'm going to multiply by it. Okay, I see a 6 is common right there, but when I could do this, I won't be a 6 over there. Okay, I see 12 and 12, so let me keep counting by 3s, 9 and 12. So I could use 12. It's a 12 in all of them. So I'm going to multiply each one of these by, each term by 12 to get rid of these fractions, okay? So I end up with 12 times 1, which is 12, but divided by 6. 2 times 12 is 24 divided by 3, and put your m. 1 times 12 is 12 and divided by 4. And let's just see what we get. That's going to give us 2 minus 8m greater than or equal to 3. Now you just got a basic two-step equation without the fractions. So I'm going to subtract 2 from both sides. So you get negative 8m greater than or equal to 1. You're going to divide both sides by negative 8. Since you're dividing by a negative, flip the symbol. So greater than or equal to is going to flip to less than or equal to. Please do not put m as less than or equal to negative 8. In order for it to be negative 8, the negative 8 would have had to been in the numerator. That's negative 8. 1 divided by negative 8 is just negative 1/8, okay? It's a fraction. That's all you can do. So don't do that. Now somebody's saying, well, that's not an even number. I don't care that it's not like a whole number or the opposite of a whole number. It's some fraction. So who cares? You still put negative 1/8. And this would be like 0/8 or 0. This would be negative 2/8. This would be negative 3/8. And this would be positive 1/8. So I hope you still order the number line the way you want to. I'm just putting it in eighths instead of like whole numbers are the opposites. Okay, I'm going to put a closed circle on negative 1/8. And because it's flipped to less than, I'm going to shade to the left. And in interval notation, I'm just going to write this from left to right. On the left, we have negative infinity. On the right, we have positive or negative 1/8. So in interval notation, this is what it looks like. But you're going to use a bracket because it's a parentheses. It's a closed circle on that negative 1/8, okay? Again, if this stuff isn't making sense, y'all let me know. I know I'm working with the other group, but just pause the video and say, Miss Blue, I'm lost. Plus, tomorrow I'm going to let you all have like a teaching session where you help one another, okay? All right, let's take a look at number 2. Number 2, since this division bar extends all the way across, I need to get rid of it first. I'm going to multiply the whole side by 3, and I'm going to multiply the 7 by 3. These 3's are going to cancel, and I'm left with just what's in the numerator, which is 1 minus 2n. And over here, 3 times 7 is 21. Now it's just a basic 2-step. Now you can get rid of that 1. Change the sign. And they cancel. I'm left with negative 2n. I'm going to divide both sides by negative 2. Okay, at this point, I'm dividing by a negative. So automatically, less than or equal to is going to flip to greater than or equal to. Bring my negative 10 down and put my n on that side. So I have negative 10 greater than or equal to n. So when I get ready to graph this thing, I know I'm going to have negative 10 here, negative 9, negative 8, negative 11, negative 12. And I know it's going to be a closed circle at negative 10, guys, but here's the problem. Some students get confused on which way it goes. And I told you if the variable doesn't come on the left side first, you can rewrite it. So I know I flipped it once, but I'm going to flip it again. So I'm going to call this a double flip because I like to see my variable first. I'm going to put n on this side and negative 10 over there. I'm going to flip it back from greater than to less than. So it's easy to see which way to shade. Like some students need that. Some students don't need to rewrite it. If you don't need to rewrite it with the variable first, then don't worry about it. If you can see that negative 10 has to be greater than all of your answers, therefore all your answers need to be less than negative 10, fine. Shading everything that's less than negative 10. But if you can't see that, guys, rewrite it with the variable first. All right, so on the left, if I write this from left to right, on the left I have negative infinity. And let me erase that so I can have more room. And on the right, it's going to negative 10. So this is going to be negative infinity to negative 10 with a bracket because, again, it's an equal to sign underneath it. It's closed. So this one was a double flip. The first flip was because I divided by a negative, okay? The second flip is because I chose to rewrite it with the variable first, okay? Now these are special cases. So here we go. The special cases, you got to pay attention to the way the expression is read in the end. Do you have a true inequality statement in the end, or do you have a false inequality statement in the end? Because the variables are going to cancel on both sides. And you all know from dealing with equations, when we have variables that cancel on both sides, you're either going to end up with no solution or infinitely many solutions. So let's take a look at these two cases. All right, so here I'm going to use the distributive property. So I have 4y, and then 4 times negative 1 is negative 4. Then you're going to have greater than or equal to 6y minus 2 times y, which is negative 2y. Negative 2 times negative 3 is positive 6. And on the right side, I can combine those two because they're on the same side. So 6y minus 2y is 4y. So but I have 4y plus 6. And you should be able to tell. Some people will say, oh, that's no solution. Well, you don't know that yet because you got to read the inequality statement. It's not an equal sign in between them. So what I'm going to do is get rid of the 4y from one side. But what happens is I actually succeed in getting rid of it from both sides. And what's left on this side is a negative 4. And it says negative 4 is greater than or equal to what's left on this side, which is 6. So is negative 4 greater than or equal to 6? And that would be a no. So we get no solution. You don't even worry about trying to graph these, okay? There is no solution. Hold on one second, guys. Hello?
Have they called for lunch?
Mm-mm.
Did you order a lunch from what's his name?
Because I'm working. I didn't order. I didn't know anything. I forgot. I thought this was on the day I was going to be out. So I didn't order anything, but I'm making a video right now, and I'm just working on my class. I don't want to take a whole bunch of stuff home. Okay. All right, then. Bye. Okay, sorry about that, guys. So negative 4 is not greater than or equal to 6, so the answer is no solution. But you only get these special cases if the variables cancel on both sides, all right? Okay, let's take a look at this last one, case 2. I'm going to get rid of nothing. There is nothing on the left side or right side to combine to try to make the size smaller. So I can go ahead and get rid of positive 2x with a negative 2x. And on this side, I'm left with 5. And then it says 5 is greater than or equal to negative 7, because that's what I'm left with. So is 5 greater than or equal to negative 7? And that would be a yes. It may not be equal to negative 7, but it's definitely greater than negative 7. Because it's a yes and the variables cancel on both sides, your solution is infinitely many solutions. All right, let me see how long this video took, because I think that's all we're going to do for today. And tomorrow I'm going to let you practice, okay? All right, but if I decide to put something behind the video, you will see it as attached as activity number 2 on Google Classroom. If I didn't attach anything because this video is so long, then you will only have activity number 1, which is just this video. And you're just practice tomorrow. All right, thanks, guys.